Hello everyone. Here in this session, I will be going to discuss about Routh stability analysis example number 5. This is special case 1 and linear control systems lecture series on linear control systems lecture number 36. So this is example 5 special case Routh stability analysis. Solved example. What is the example 5? A closed loop control system has the characteristics equation given by s to the power 5 plus 3s to the power 4 plus 2s cubed plus 6s square plus 6s plus 9 equals to 0. So this is the fifth order polynomial equation. This is the fifth order polynomial equation. Investigate the stability using Routh-Hurwitz criterion. Investigate the stability. So solution, what is the solution? Step number 1. The given characteristics equation is s to the power 5 plus 3s to the power 4 plus 2s cubed plus 6s square plus 6s plus 9 equals to 0. In this case, this is the fifth order systems or fifth order polynomial equations. So fifth order systems. Coefficients of s to the power 5 is 1. So s to the power 5 coefficients equals to what? 1. S to the power 5 coefficients equals to 1. Then s to the power 4 coefficients equals to 3. So s to the power 4 coefficients equals to 3 and s cube coefficient is equals to 2. S square coefficient is equals to 6 and s to the power 1, s to the power 1 coefficient is equals to 1 and s to the power 0 coefficient is equals to s to the power 0 coefficient is equals to 9. This is the s to the power 0 coefficients 9 equals to 0. So this is the coefficients of s to the power 5, 4, s cube, s square and s to the power 1 and s to the power 0. S to the power 1 and s to the power 0. Then step number 2. Let us consider a system with characteristics equation s to the power 5, 3s to the power 4, 2s cube plus 6s square plus 6s plus 9 equals to 0. It can be stated that the necessary condition for stability of a system are as. So what is the necessary condition? This is very important for Routh-Hurwitz criterion or Routh stability analysis, because first case necessary condition, the characteristics equation or characteristics polynomial equation have all the coefficients real and positive. In this case, s to the power 5 coefficients positive and real. S to the 4 coefficient 3, this is also positive and real. S cube coefficient 3, this is also positive and real. S square coefficient 6, this is also positive and real. S to the power 1 coefficient 6, this is also positive and real. And s to the power 0 coefficients 9, this is also positive and real. So first point satisfied. Then second point, none of the coefficients of the polynomial is 0. In this case, s to the 5 coefficients 1, so not equals to 0. S to the 4 coefficients 3, this is also not equals to 0. Similarly, s to the s cube, s square, s to the power 1, s to the power 0, coefficients not equals to 0 because 2, 6, 6 and 9 coefficients. None of the powers of s between the highest and lowest powers of s is missing. In this case, s to the power 5, s to the 4, s cube, s square, s to the power 1 and s to the power 0. None of the power of s between the highest and lowest power of s is missing. So this is also satisfied. So s to the 5, 4, 3, 2, s to the 1 and s to the 0. No missing power in this equation. The necessary conditions are satisfied. It is to be highlighted that these are only necessary conditions but not sufficient. So this is necessary condition but not sufficient. All the stable systems must satisfy this condition. That means all stable systems must satisfy this, and this conditions. And but system satisfying all these conditions need not be stable. So this is the very important for necessary condition. Then what is the necessary condition? The necessary condition help us to eliminate polynomial with negative coefficients or missing power of s by visual inspection only. If the characteristics equation satisfies all the necessary condition, it is a possible nominee for examining further. For stability, Routh and Routh have independently established the conditions for stability of S systems without actually finding out the roots. The criteria is known as Routh-Hurwitz criteria for stability. This criteria determines how many roots of the characteristics equation lie in the right half of the S-plane, because we know that if all the roots left-hand side of the S-plane, then system will be stable. But Routh's criteria determines how many roots of the characteristics equation lie in the right half of the S-plane. Right half of the S-plane means this is the imaginary. If this is real, this is the right hand side part, right hand side. And Routh criteria determines how many roots of the characteristics equation lie in the right hand side. That means this side. If all the poles and zero left hand side of the S-plane, this is the left hand side, then system will be stable. This system will be stable. This test also determines all the roots of the j omega axis so that their multiplicity can be found out. The polynomial coefficients are arranged in an array called Routh array. So next case, determine the Routh table or Routh array or sufficient condition. This is the characteristics equation, and the Routh array is constructed as follows. Each row is identified in the descending order of S, descending order of power of S. The first row contains coefficients of alternate power of S starting with the highest power S. So first row starting this point, and next this power 3, and then S to the power 1 power, S to the power 1 power. Similarly, second row or next row contains coefficients of alternate power of S, and starting with the second highest power S to the power 4. So S to the power 4 coefficient 3, and next S square coefficient 6, and S to the power 0 coefficients 9. This is the second row or next row. Then the other rows are constructed in a systematic way as indicated in the procedure given below. So step number 3. What is the step number 3? Step number 3, arrange all the coefficients of equation 1 in 2 rows. Row 5, that is S to the power 5. What is the coefficients? 1, 2, and 6. 1, 2, and 6, because this one is to the power 5 coefficients, and alternate power, this is the 2, and again alternate power S to the power 1 coefficient 6. Similarly, next row S to the power 4 or row 4, 3, 6, and 9. 3, 6, and 9. 3, 6, and 9. This is the 3. This is 6. And this is the 9. S to the power 4 row or row 4. Row 4. Then construct Routh table. So this is the Routh. Step number 4. From these 2 rows, we then subsequent rows to the Routh array. Row 5, S to the power 5. Row 4, S to the power 4. Row 3, S cube. Row 2, S square. Row 1, S to the power 1. Row 0, S to the power 0. So put here S to the power 5. That means 1, 2, and 6. 1, 2, and 6. Similarly, s to the power 4, 3, 4, and 3, 6, and 9. 3, 6, and 9. Then calculate others row, row 3, row 2, row 1, and row 0. Suppose A, B, C, D, E, F, G, H, I, J, K, L. So calculate A to L. And what is the value of A? What is the value of A? A equals to, again, A equals to 3 into 2. 3 into 2. So 3 into 2, write down here 3 into 2 minus 1 into 6. Again, minus 1 into 6. 1 into 6. So write down here 1 into 6 and divided by starting value 3. This is the 3 starting value, and this value equals to 0. And B equals to what? B equals to 3 into 6. 3 into 6. Why 3 into 6? 3 into 6 minus 1 into 9 divided by this first value 3. So here write down 3 into 6 and 1 into 9. 3 into 6, 1 into 9 divided by 3. This is equivalent to 3. And C equals to what? 3 into 0 minus 1 into 0 divided by 3, because 3 into 0, this is the 0 point, and this is also 0 position. 0 position. So 3 into 0, 3 into 0, and 1 into 0. 1 into 0. So then write down C equals to value 0. And next, so A, B, C complete. But in this case, first column, third row, first element, that means A equals to 0. If A equals to 0, D undefined. So this is the special case, and case number 1. Why undefined? Suppose D equals to A into 6. A into 6, so 0 into 6, A equals to 0, A into 6 minus 3 into B. 3 into B equals to 3. B equals to 3 divided by 0. Something by 0 equals to undefined. So this is, in this case, Routh criteria fails. So this is the special case, and solve this special case by using Routh-Hurwitz stability analysis. So in Routh array, the third element in the first column is 0, and the Routh criteria fails. At this stage, this is already discussed, Routh table, and 0, 3 is 0. So D equals to undefined. In this case, first column, third element, row 3, first element 0. So in this case, Routh criteria fails. So what is the process for solving? So next case, step number 6, first case, or a special case number 1. So S5, S4, S3, S2, S1, S0, put the value 1, 2, 6, and 3, 4, 3, 6, 9, and determine D, E, F, G, I. So what is the 0? First case. Sometimes the first entry in particular row may turn out to be a 0. Since the calculation of next row enters involves division by the 0, the process of constructing the Routh array stops there. So this is the very important, stop there. And to overcome this difficulty, the following procedure may be adapted. So what is the procedure? So this is the Routh table. First method, what is the first method? Replace the 0 in the row by epsilon. So in this case, this is the 0. So replace this 0 by epsilon, and this epsilon tends to 0 but not equals to 0. This epsilon tends to 0 but not equals to 0, and this is always positive. So this is epsilon, epsilon tends to 0 but not equals to 0. Proceed with the construction of the table. Consider the enters of the first column in the third row of the array by letting epsilon tends to 0. From the positive side, the Routh array is found as follows. So what is the Routh array. So put here epsilon, because this is A, this is B equals to 3, and this is C equals to 0. So put next value D and calculate D, then E, F, G, H and others value. So what is the D? D equals to epsilon into 6. D equals to epsilon into 6. Epsilon into 6. So write down epsilon into 6. Minus 3 into 3. Minus 3 into 3. 3 into 3. 3 into 3 divided by epsilon. Divided by epsilon. That means 6 epsilon minus 9 divided by epsilon. And this is equivalent limit. Epsilon tends to 0. 6 epsilon minus 9 by epsilon. Epsilon cancel. 6 minus 9 by epsilon equals to minus infinity. So D equals to minus infinity. And what is the value of E? E equals to epsilon into 9. Epsilon into 9. Why epsilon into 9? This epsilon into 9. And 3 into 0, right? 3 into 0. Divided by first value. This is the epsilon. And the value of epsilon is cancel. 9. E equals to 9. And what is the value of F? F equals to 0, because epsilon into 0 minus 3 into 0 divided by epsilon, and this magnitude equals to 0. This magnitude equals to 0, because this is 0. Epsilon into 0 minus 3 into 0 divided by epsilon. So F equals to 0. Then calculate GHIJKL. So what is the value of G? Calculate the Routh row 1 or s to the power 1, that is G, H and I. Row 5, s to the power 5, 1, 2, 6. Row 4, s to the power 4, 3, 6, 9. Row 3, s cube, epsilon 3 and 0 bit determine s square coefficient D. So what is the D, E, F and G? What is the value of G? What is the value of G? Equals to D into epsilon, D into 3, sorry, D into 3, D equals to 6 epsilon minus 9 by epsilon. So put here D and into 3 divided by, so minus epsilon into E. Epsilon equals to epsilon and E equals to 9. Then put here 6 epsilon minus 9 by epsilon and limit epsilon tends to 0. Then 3 minus cancel epsilon, 6 epsilon minus 9 by 3 cancel out. Then this is the value of 3. So this is the value 3. C equals to 3. Then H equals to what? H equals to 0, because Z into D into 0, epsilon into 0 divided by G, divided by D. So Z, H equals to 0. Similarly, I equals to also 0. Similarly, I equals to also 0, because D into 0 minus epsilon into 0 divided by D, and I equals to 0. GHIL, sorry, I, this is I, and then calculate JKL. JKL. So what is the value of J? This is step number 10. Calculate row 0 or s to the power 0, that is J, K and L. So first construct the Routh table 2, 3, 1, 0, and then calculate the value J. So what is the value of J? J equals to Z into E. J equals to Z into E. That means G equals to 3 minus 9 epsilon square by 6 epsilon minus 9 by 9 into 9 minus D into 0 divided by 3 minus 9 epsilon square by 6 epsilon minus 9, and this cancel out. Then only 9. Then K equals to 0 and L equals to 0, because K equals to Y 0, K equals to Z into F equals to 0. That's why K equals to D into L. So this is also 0. D into I, this is also 0. L equals to 0. Then this is the final table. What is the final table? Routh final table. Put the value A, B, C, D, F, G, H, I, J, K, L and construct the Routh table. Final table. Epsilon 3, 0, minus epsilon 9, 0, 3, 0, 0, 3, 0, 0, and 9, 0, 0. So then Conclusion. What is the conclusion? In Routh table, this is the first column. And in first column, this is positive, this is also positive, this is also positive, but this is negative. So one sign change positive to negative. This is also positive, so negative to positive, and two sign changes. So two roots right hand side of the S-plane and system will be unstable. So write down here. In the first column of the Routh array, there are two changes in sign of the elements epsilon 2 plus epsilon 2 minus infinity. So plus epsilon 2 minus infinity and minus epsilon 2 in plus 3. Plus 3, it is concluded that the system has two roots with positive real parts, and as such, the system is unstable. So this is the Routh final table. Thank you.